Welcome to Study Loop.
In this problem, we have a block connected to a disk through a wire. We're given a diameter, or twice the radius of the disk, which is 35.6 centimeters. We're given a mass, smaller m, of the block. We're given the distance where the block has descended to be 1.65 meter per second squared multiplied by t squared. We're given so d is the time dependence of the distance. That's the block distance, and L is the distance at a certain time. So for part A, velocity is simply the time derivative of d, which is 3.3 t meter per second. Acceleration is time derivative of velocity. So this is simply 3.3 meter per second squared. So we observe that this acceleration is a constant. Okay. For part B, we want to find the final velocity when the distance is 1.5 meters. So we use the relationship v final squared minus v initial squared equals 2al. The initial velocity is 0, so we can directly solve for v to be square root of 2al. Plugging in the numbers for a and l, we find this v to be 3.15 meter per second. For part C, we want the moment of inertia for the disk. We set up an equation of energy conservation. Initially, there is gravitational potential energy of the block, mgl. And finally, after the block descends, there is kinetic energy for both the block and the disk. So for the block, we have 1/2 v squared times m. For the disk, we have 1/2 I omega squared, where this omega is just the v over r. Okay, so from this equation, we can already solve for I, which is 2 mg L r squared over v squared minus m r squared. This is 0.348 kilogram meter squared. For part D of the problem, we first analyze the force felt by the block. It feels the gravitational force mg, feels the tension due to the wire T, and using Newton's second law, we know mass times the acceleration equals mg minus t. It is mg minus t instead of t minus mg because we know the block descends. Okay, then t is obviously equal to ma minus mg. We have already solved for a to be 3.3. We're given m, so we can directly plug in the numbers and get tension equals 36.4 Newton.